guidance of Dr. Pratna ma'am, HOD of Biotechnology. As I am presenting the topic on bioreactors, which is also called as fermenters. Today I will be covering the topics upon introduction, types of bioreactors, explanation and definition, visual representation of some bioreactors and their advantages and many things. Introduction upon the bioprocess and bioreactors. Bioreactors or fermenters is the heart of the fermentation or bioprocess technology. Is the fermenter or bioreactor. A bioreactor is basically a device in which the organisms are cultivated to form the desired products. As what we want, we can take. We can obtain any biological things by bioreactors by going through bioprocess and etc. It is a containment system designed to give right environment for optimal growth of metabolic activity of the organism. There are many types of bioreactors. For example, continuous state bioreactor, airlift bioreactor, fluid bed bioreactor, packed bed bioreactor, photobioreactor, and membrane bioreactor. Coming to the first one, continuous state bioreactor. Continuous state bioreactor is also a wet or batch reactor. Mixed flow reactor or a continuous state bioreactor is a common model for chemical reaction in which chemical engineering and environmental engineering. The most widely used continuous process based on CSTF, which is by continuous state tank fermenter, is the activated sludge process used in wastewater treatment in industry. Advantages of this bioreactor is continuous operation, as it has a propellants in the bottom of them. It has continuous operation system, good temperature control due to its structure, easy adapts to two-phase runs, and it has got a good control. Simplicity of construction, as it is cylindrical, in cylindrical form. Low operating or low cost, which is cost friendly, easy to clean. Coming to the second one, airlift bioreactor. Airlift bioreactor are quite similar to the still tank reactors, except for the impellers, where in continuous state bioreactors, the impellers are in the bottom of the reactor. Whereas in airlift bioreactor, there are no impellers, but there is an outlet of gas from the bottom of the reactor, where the gas is forced through the bottom and the reaction goes on. So this is a gas liquid bioreactor, which is based on the draught tube principle, in which the reaction is compressed air used for aeration and agitation. In this reactor, the aerator is a glass grid which helps to pass the humidifier air, which is useful for mixing and oxygenation. Airlift reactors are in use for culturing different hairy roots, but they have their own backdraws as well. A major drawback is reactor is formation of dead zone due to insufficient mixing. Due to air, there will be some insufficient mixing goes on, where the air cannot reach some parts, so it forms a dead zone. So insufficient mixing and non-uniform nutrient supply caused by high biomass density. As we should produce high and a large amount of things, so there will be no good supply of nutrients, and the gas cannot reach everywhere. So these limitations badly affect the growth of hairy roots and secondary metabolite production. So advantages of airlift bioreactor: simple design, no moving parts or agitator for less maintenance, less risk of defects, easier sterilization, low energy requirement versus still tank. Obviously, it doesn't need the energy for the moving parts, as there is no impeller or agitator. Greater heat removal versus still tank, as the airlift bioreactor, it doesn't need the heat plate to control the temperature. It doesn't need the heat bed has only gas is needed, and there is no that thing which goes on movement and etc. Because of broad tube which is inside the bioreactor can be designed to serve the internal heat exchanger. It is different to the split tank bioreactor and needs the high coat or plate surrounding the tank to make warm bioreactor. It is clear enough that the AIRLIFT bioreactor has greater heat removal compared to split tank, and it is also a low cost mechanism. These are some industrially used AIRLIFT bioreactor, as it is in big in size, and these are normally used in labs, and these are used in industries. Coming to next one, fluid bed bioreactor. A fluid bed bioreactor is a type of reactor device which can be used to carry out the variety of multiple phase chemical reactions. In this system, the fluid is passed through a solid granules material a high enough speed to suspend the solid and cause it to behave as a fluid. Fluidized bed bioreactors offer a much higher efficiency in heat exchange compared to fixed bed and better temperature control due to the turbulent gas flow and rapid circulation. At the same time, the high gas velocities do not cause any pressure drop issue, and smaller catalyst particles can be employed. Coming to next one, packed bed bioreactor. Packed bed bioreactors are a tubular system of reactions in which the packed with immobilized enzyme or microbial cells as catalysts. Different techniques such as encapsulation, cross-linking, covalent bonding, and absorption are generally used for immobilization process. Packed bed bioreactors are very versatile and are used in many chemical process applications such as absorption, distillation, stripping, separation process, and catalytic reactions. Across the diverse applications in which they are used, the physical dimensions of the beds can vary greatly. So coming to next one, it is photobioreactor, refers to an cultivation system designed for growing photoautotropic organisms such as using artificial sources or sunlight to facilitate biosynthesis. PBRs are typically used to cultivate microalgae, cyanobacteria, and some mosses. So photobioreactors are specialized bioreactors for culturing phototropic organisms. Given the correct conditions, almost any algae, cyanobacteria, seed, or plant cell can be grown efficiently in a photobioreactor. So in large scale photobioreactor, we use sunlight, and in small scale in labs we use light as a photo source as a growing factor. So coming to the next one, membrane bioreactor. Membrane bioreactor is a combination of membrane process like microfiltration or ultrafiltration. This is biological wastewater treatment process. The activated sludge process. It is now widely used for municipal and industrial waste treatment. The advantages of membrane bioreactors are systems over conventional biological systems include better effluent quality, smaller space requirement, and ease of automation. Specifically, membrane bioreactors operated at higher volumetric loading rates, which results in lower hydraulic retention times.